So here we have our basic soldering tools, our solder, PCB and some resistors, with the iron on my right side as I'm right-handed. It's always important to keep your work area tidy and free from clutter with the components to be soldered neatly arranged. When soldering, we're trying to connect two bits of metal together. This usually means the leg of a component to the metal pad of a PCB. For this to happen successfully, we need the correct amount of heat on both bits of metal and that the surface is clean. To address this first requirement, let's look at the soldering iron. Here we have a good quality Weller temperature controlled iron, but any iron between 20 and 40 watts is perfect. If you are using a temperature controlled iron, try and get one that's nice and dusty like ours, and setting it to around 340 degrees is perfect for leaded solder. You'll also want to use a fine tip of around 1mm. Using leaded solder is much preferable to lead free, as leaded has a lower melting temperature, which reduces the chances of damaging the pads and the components. But as long as you wash your hands after soldering and can resist the urge to eat the solder, it's perfectly safe to use. When using solder, you will notice that smoke is given off. This is not actually the solder itself, but rather a thin core of flux within it. This flux reacts with any dirt or grease on the surface and smokes away, leaving a clean surface for the solder to adhere to. Furthermore, if you suspect that the surface you're going to solder is not completely clean, you can clean it first with isopropyl alcohol, also known as IPA. You will want to make sure there's an adequate ventilation when soldering, or you may wish to use a small portable smoke extractor. To keep the tip of your iron clean, we can use a wet sponge. So we will add some water to our sponge before we get started. When soldering, always use helping hands to hold the PCB. This will keep things steady and make the process easier. So we're going to be soldering some resistors, so we remove them from their paper and fold them into little N shapes, ready to be placed on the PCB. We then identify the correct position for the component by referencing the workbook and the white silkscreen marking on the PCB. When the legs have been put through the correct holes, we bend them slightly on the other side to hold them in place. Don't bend them too much or it can make soldering a little tricky. Before soldering, we need to make sure that the tip of our iron is clean and free from contaminants. To do this, we simply place a healthy amount of solder on the tip, which should be up to full temperature, and then we wipe the tip on our wet sponge. Repeat this until you're left with a clean, shiny metal surface. So in soldering, it's important to make sure that we are transferring enough heat to both the metal pad and the leg of the component. First, bring in the iron and place it on the surface of the metal solder pad, making sure it is touching the leg of the component. Bring the iron in at a steep angle relative to the board. Now that the iron is in place, do not move it until the job is finished. Next, bring in the solder and again push it at the point where the leg meets the solder pad. If the area is sufficiently warm, the solder will melt and its surface tension will naturally draw it into the hole. Use as much solder as required. It's always easier to remove excess solder than to troubleshoot a poor solder later. Once you have enough solder, remove it and then remove the iron. Once all your parts are soldered, you can then snip the legs of the components. And there we go, there's all our components now nicely soldered with their shiny, conical, volcano-shaped solder joints. And so as long as you remember to always follow the same procedure, applying consistent heat from the iron, you're not tempted to move it at any stage, use good quality solder, and you keep the tip of your iron clean, you should never have any problems.